I wanted to give a quick review from section 3.3 over parabolas and quadratic graphing, and I wanted us to begin with vertex. And we're going to pretend that my drawing that I have here is a really good parabola and a very distinctive vertex. So I drew a dot right up at the top, and I said that our vertex is at -2, 6. And we should be used to my drawing by now so that we can pretend that I have done a very fabulous job. So if we have this, and I hope that by now you can get this in a good graphing calculator, if I were to give you the equation for this, of course, I hope that by now you can generate this equation for yourself if you, because you know where the vertex is, and you also can see what these zeros are, that you ought to be able to determine the equation for this. That's another lesson for another day. But for now, let's just talk about the vertex. In your textbook on pages 270 and 271, it asks you in the first set of problems to do to simply find the vertex, and it gives you diagrams and graphs of them, and you can find them, and it also gives you equations. You know how to do that in your calculator. To go to your second button on your calculator, and then calc, which is the trace button, and then you're going to go to left bound, and you're going to put your little cursor on the left side of that mountain, and then hit enter, and then on the right side of that mountain and hit enter, and then you're going to it's going to ask you if you want to guess, and you're going to say no, you don't want to guess, and that's that. Okay, remember that. All right, but that's what you're going to have. You're going to find the vertex on your own, and then you can label that vertex. It's also going to ask you for the axis of symmetry. I can take now a marker here, and I can draw me a line, an imaginary line right down the middle of this parabola. And if you can take this and fold it in half, that's going to be my axis of symmetry. And my axis of symmetry here is always going to happen along the vertex, and it's always going to be along the x-axis. See, this dot is on the x-axis. It's going to be x is equal to whatever the x value of my vertex is. So x equals -2. Keep in mind it must be a line. Therefore, you must have the x equals that -2. Also, because this is a downward opening parabola, it is going to be a maximum value. So you're also going to say that this has a maximum. It says to determine whether there is a maximum or minimum value. So it's got a maximum value, and state what that value is. So it is 6, because that is our y-coordinate of our parabola. And then you ought to be able to graph it, sketch a quick graph. It's at least as good as mine, I'm sure. And then while we're here, even though just like you would have to on exercises 31 through 40, it asks you to also determine whether there is a maximum or minimum value. Find that value, which we've done. Also, let's talk about the range. Let's look at this graph, and we can also talk about the range of this graph. This graph is downward opening. So this graph, if we're talking about the range, keep in mind we're going to start up here on our y's, and we're going to either look up or down. And since our graph is downward opening this time, we're going to look down. So our range for this particular parabola is going to be no taller than 6. It goes no higher along the y-axis than 6. So it's going to be from -infinity in this case, and it goes no higher than 6. It does include 6, so we are going to as well. And that would be our range. It also asks us, where is this graph increasing and where is it decreasing? And I did not mention this in class, and I would not put this on your test, but I do want, again, for those of you that really want that last detail, increasing means where is my graph, where does it have a positive slope? It is increasing. Again, we're going to split our graph in half. We're going to split this parabola in half. And along this half of the graph, we would have to be climbing uphill if we were going to the top of a ski slope. Our slope is positive here, so our graph is increasing. And that's what you would put. But now we are going to, when we're talking increasing and decreasing, we're talking about our domain for what x values is our graph increasing or decreasing. Even though our slope is going upward, for what x values is it increasing or decreasing? So it is a little bit confusing to see because you're looking uphill and going uphill, but you record your x values. So we're increasing here, starting at negative infinity along our x-axis, and we keep increasing and we keep increasing and we keep increasing until we get to what point? Until we get to negative 2. Okay? And another thing that you need to recognize is that you would only use a parenthesis. And that's because at our highest point, are we increasing? No. We're at the top of that ski slope. And so we are neither increasing nor decreasing up there. So you use a parenthesis. And then where are we decreasing? We are decreasing starting here at that negative 2. And then we begin to go downhill. And we continue to go downhill until we get to the bottom of our hill. So I probably chosen a different color. Starting from negative 2 at our x values, we are decreasing. Starting at negative 2, again, not a bracket, but a parenthesis, and going all the way to infinity, this function is decreasing. If this were an upward going parabola, we would be, those increasing and decreasing would be swapped. Okay? I'll post another one on section 3.4 in just a little bit. Have fun.